Hello everybody, welcome to my presentation about Anti Evil Maid, the status and future plans for Qubes OS development of this feature. For those who don't know me, I'm Michał Żygowski. I work as a firmware engineer at FreeMDep. I'm a firmware guy doing core boot. I maintain certain parts of the projects, certain mainboards which are listed here. I'm engaged in open source firmware since 2017 when I joined FreeMDep. And yeah, I'm mainly interested in enabling various advanced hardware features in the processors. And I also occasionally develop trench boot. So I recommend to watch my previous presentations and my colleagues' presentation from the last summit about the Anti Evil Maid. We have been also talking about the progress, what the project is, what is working, what is not, what hardware we use, etc., and the plans we had back then. So what, in short, the Anti Evil Maid is? It's basically a set of software components and scripts developed by Qubes OS team and gathered under the Qubes Anti Evil Maid repository. The goal of this feature is mainly to protect against evil maid attacks. So if you imagine staying in a hotel, for example, you leave your laptop in your room and you are absent. A room service comes in, sees your laptop, and a nasty idea in a maid came to her mind, and she or he decides to install some kind of keylogger into your bootloader, or something that injects something malicious into your operating system components. And then she came back some time later for room service again and reads out the secret information you typed in. And then she suddenly becomes an owner of your device. So basically this set of packages and scripts is aimed to prevent such attacks, or at least detect them. So typically when everything is configured well, this is the screen you will see normally when booting Qubes OS with Anti Evil Maid enabled. So what we actually need to get the Anti Evil Maid working. So there are two main things that your system device needs to support and basically have. First one is the TPM, which stands for the Trusted Platform Module. It is a specialized chip that aids various cryptographic functions in the system. It can store measurements and hash of the components that were, for example, executed during the boot process of a device. It doesn't has to be limited to firmware components. It also has to may hold measurements of the OS operating system components you have launched. Typically, it is available on almost any device nowadays, usually in a form of a firmware TPM, which is integrated into the chipset or CPU. However, there are some cases where even if TPM is available, it won't work with the Anti Evil Maid because AMD FTPMs are buggy, or at least have limited functionality, which will not allow us to use the second feature which we need for the Anti Evil Maid to work, which is the DRTM. So DRTM is a dynamic root of trust for measurement, which is like a kind of silicon vendor technology that allows you to re-establish the trust in your system in a secure manner. So this basically adds an extension to the typical instruction set of the x86 CPU and possibly other CPUs in the future, which allows you to securely measure the components at a given point of time. So what we use it for is to measure these operating system components independently from the firmware, right? And yes, it needs to be, this capability of this dynamic launch needs to be present in the processor and sometimes chipset in order to actually make an use of it. The main noticeable difference in the TPM measurements is the availability of the measurements in PCR 17 and 18. For example, in the case of Trendwood, which is like a separate set of measurements that are only unlocked when you have actually performed the dynamic launch. But how to deliver the DRTM to our system components? That is where Trendwood comes with help. So Trendwood is, let's say, it's a framework that integrates into our operating system components to deliver us the security engines and mechanisms to actually perform this dynamic launch. And current our Anti Evil Maid efforts are basically focused on integrating Trendwood into Qubes OS system components. So a little bit about the status of this integration compared to the past year. So we managed to finish two phases of the whole project, which is update to the newest Trendwood Wood protocol, because we are still not yet finalized the interface and the methodology of performing the dynamic launch for the open source software components like Linux and Zen. It has the boot protocol tends to slightly or more significantly change. So this phase focused on getting everything rebased on the newest code base and then retesting everything what we have developed so far. And second milestone we have finished was the already mentioned by Marek AMD support for the Anti Evil Maid in Qubes OS. So this is something new that wasn't present in the initial Anti Evil Maid implementation. If you look back at the very first sources, it was only available for a certain set of Intel hardware with TPM 1.2. So today we are in the state where we can use even AMD machines with TPM 2.0 to perform the dynamic launch and actually leverage the Anti Evil Maid feature. Yes. So a little bit more about the updates we also did besides the planned features I just presented. So last year my colleague did a little bit of discussion that Qubes is not so friendly to freshmen, right? Also Marta was saying that copying to DOM0 is dangerous, you don't want that, but on the other hand, you sometimes need to do so, and it is hard, right? So we try to simplify things. In order to actually get this Anti Evil Maid working with Trendwood, we have to install the custom components, because we are still in the process of reviewing and merging possibly the patches into the Qubes components. So in order to deploy everything smoothly, we have prepared the building of the packages in the continuous integration, and we have set up even an Anti Evil Maid testing repository that holds these components and can be installed in a very simple manner, like you would install any Qubes packages in DOM0. You just simply add a definition of a new repository and pass it to be enabled to do Qubes DOM0 update command. Of course, the downside of this repository is that we are still basing on Qubes release 4.2. So yes, the rebase onto the newest components like Zen and Grab are still on the roadmap. Yes, okay, so we have all these things working. We have like Intel hardware supported, AMD hardware supported with TPM 1.2, TPM 2.0. So what else do we want? Well, if we look back at the Trendwood testing, one could see that we mainly tested it in some random hardware that was pretty much cheap and quite available, but these machines were running typically some proprietary firmware. Yes, the reason behind these decisions is that hardware that is actually dynamic root of trust or measurement capable is pretty much hard to find. You cannot find these capabilities on some lower end devices, processors, right? Secondly, you need a proper firmware support in some cases to get the DRTM working. So as a preparatory step for getting it working on open source firmware, I have presented a demonstration of running this Strange Boot Anti Evil Maid on the Dashara open source firmware supported Protectly network appliance device. It was on Zen Summit this year. If somebody was there with me, then they probably saw. However, there are still some downsides to using Protectly devices. First of all, they are good for development and testing because they have the serial port, which simplifies the debugging. But like I said, it is more like a network appliance. The Anti Evil Maid is rather for devices that are portable. So in my opinion, the Anti Evil Maid shines the best when it is like installed on a laptop, right? So the goal I have set for myself is to get the Anti Evil Maid working on a Qubes-certified laptop. And of course with open source firmware. So my choice for the nearest future was the certified Nova Custom NV40 series laptop, which is based on a 12th generation Intel Core processors. So it is relatively modern, right? Because these processors were like released maybe 3 years ago, right? It is already Qubes certified, so it passes my main requirement. It is open source firmware supported, so we release firmware updates via Dashara. And of course, it is thankfully DRTM capable. Intel did a small, how to say, a small favor for us and enabled the DRTM capability on a wider range of their processors since this generation. So it is like a, I think, big step forward to have a wider selection of hardware that we can test it on. Of course, there are problems with these devices as well, because despite they are relatively modern, they are already not in production anymore. So Nova Custom is already running out of stock of these devices, so even if we release something, it will be very limited edition stuff. And another, I would say, disadvantage I have found is that you cannot enable DRTM capability without actually configuring bootguard, or at least that's what I'm. That's what I think for now, because I haven't found a way to actually get it working without it. Because the TXT need to take some information from the bootguard structures, what is supposed to be measured and how it is supposed to be configured. So yes, and this is since the 11th generation of the processors. So another change, another problem. So what I have basically reached, I have used the CBIOS firmware because we do not support UEFI yet. So I have tried to show to the end users whether their system is actually DRTM capable and whether they have configured the Anti Evil Maid properly. So what I did, I extended the Qubes OS global configuration page and the security report for additional variants that you can see on the screen. The two bottom features that are listed is the DRTM capable property and the Anti Evil Maid status, which shows you whether the service running on Qubes OS has been properly executed. So the whole DRTM flow succeeded and we have everything set up correctly. There's also a small blooper here because the certified laptop is only for UEFI flavor of firmware. But thankfully, all NV40 series with the Sharo firmware are actually certified. Oops. Yeah. Yeah. And the vessel from our customers like asking me, hey, CBIOS is not certified. And so I say, really? Okay. Of course, there are some issues because why wouldn't there be any? As I mentioned, we do not have UEFI support yet for performing the dynamic launch and booting Zen in UEFI mode. So as a result, we miss many of the setup features we typically offer with the Sharo. So like if you would like to disable the USB stack in the firmware or disable camera, whatever else there is in the setup, I don't remember really now. Secondly, most of the Sharo releases, maybe if not all today, are basically the UEFI flavors of firmware. So this is the test the configuration we test. So basically, if I produce a build with CBIOS, then I have some kind of untested configuration and different issues may appear. Second issue is that whenever I use the dynamic launch actually, so try to leverage the Anti Evil Maid, I end up in the state where certain VMs are not launching. For example, sysnet, sysfirewall, and sysUSB. So yes, as the state is for now, this defeats the purpose actually of using Qubes OS, because if I have no isolation, for what I have enabled this security feature, right? So this is the major road blocker.
Perfect isolation.
Yes, perfect isolation. No isolation at all. Yes, my prediction is that certain cleanup after the dynamic launch is still missing in Zen, in our implementation of the entrenchment. So I will have to look inside the T-boot and see what I have missed. And the third issue, Zen boots terribly slow. Like if I try to, since the selection of the Anti Evil Maid entry in grab up to the password prompt of the LUX key or TPM storage root key, it takes, I don't know, 1 or 2 minutes. That's very, very terrible, I would say. And the reason is probably as above. Some cleanup may be missing because the whole slowdown is basically on the steps where we measure the DOM0 kernel and initial RAM disk. So it takes the most of the time. Okay, just to show that I do not saying empty words, time for some demo. So imagine you are in a hotel room and some evil maid is coming. So it's time to secure your system. Okay, so I have another laptop here with me. It's a development and testing laptop, which you can judge by sending out wires here. First, I will maybe boot without the Anti Evil Maid, just to show you that the Qubes global config is showing that system is DRTM capable. Okay, let it boot, and then okay, and this is the typical boot flow when you where you type the LUX password, and then we are shortly in the login prompt for the user. Okay, now I'm start to wondering what I will do if this awkward silence will come up when this slow boot delay will just come up. I haven't thought about what to talk. All right. Okay, so let's open the terminal. Qubes OS. no, just Qubes global config. Yes, so the information is mainly sourced from the Qubes HCL report, right? So first step was to extend this page, the GUI page, about these new two fields. And secondly, extend the HCL report to extract the information. But the tricky part about these two, at least about this DRTM capable property, is that Zen lies to DOM0 about the DRTM compatibilities, because it cannot tell you that you support DRTM, of course. Secondly, the comments from the instruction set that are used to invoke the dynamic launch will cause you a virtual machine exit. So they cannot be executed in DOM0, of course. So I had to expose this information in the Zen debug log buffer. So basically, I just added a few print case in the Zen trace, and then I just parse XL demask in the report, and that's basically it. The AEM status is much simpler. I just query the systemd about the status of the Anti Evil Maid UX service, and that's it. And as you can see, it says that the service is maybe installed, but it's inactive or failed because I haven't booted yet the Anti Evil Maid entry. Yes, and maybe I will show how the demask will look like. Yes, and this we can, or maybe I will enlarge a bit so it will be more visible. No. Oh God, I have this German keyboard and I can't find the plus button.
Maybe view and just plus.
Yeah, I think it will be easier.
Zoom in.
Zoom in. Maybe once more. Yeah. And where was that again?
It was more to the top.
Yep.
Here.
Yep, here. So I have added two prints because, firstly, I can query the DRTM capability just by using CPU ID. But the tricky part on Intel platforms is that you also have to detect whether your chipset supports the DRTM capability, because, if you have a laptop, then it's easy because it's one SoC, and either it supports or not. But if you have a desktop, then you have like two components, CPU and the chipset is separate, right? And you can have a DRTM capable CPU paired with a non-DRTM capable chipset. So I have to use this special DRTM command that queries the capabilities of the chipset. And then, of course, I have to do it in Zen because otherwise in DOM0 it would cause a VM exit. Yes, so I just parse this information in HCL report, and that's how I get the DRTM capable property. Okay, time to boot the Anti Evil Maid entry. So I have prepared a special Anti Evil Maid boot device on an SD card with multi-factor authentication. So just plug it in, reboot, and now I should boot straight from the SD card. You will see that there will be a grab entry with Anti Evil Maid. Of course, it is beneficial to have it on a separate device because you can take your SD with you and prevent the Evil Maid from stealing your SD card or installing the bootloaders there, right?
Isn't this part of the slowdown?
Only up to the loading components, which you will see. It is slightly slower indeed compared to loading components from NVMe. As you can see, loading Linux takes a couple of seconds. Initial RAM disk also a couple of seconds. But the real day starts when the screen is cleared and the Zen starts booting.
There is this enabling S-launch line.
Yes, this is the extra important line here that says, okay, I want the dynamic launch, so please enable it for me. and this changed the whole boot flow of the platform and Qubes. So this is where Zen already started because it created the screen. Now it probably measures those DOM0 components right now.
Can you see what is happening if you remove the console equals none parameter? Because we disable console output from Zen in the script.
Yes, it would be possible, probably, but you wouldn't see what is measured and when because there are no prints, debug prints in this part of code. I just added them manually to see where I have these bottlenecks, right? But in general, you should see like typical Zen boot log here. Yeah, and I forgot to show you the PCRs from before the boot that they are all FFFFFF. So these PCRs are locked. So here they will be unlocked and the reset state is 000 in such case. And then they are extendable.
I guess we can use this time for like one or more or two questions.
Yeah, feel free. You can just idle on the.
Okay, so this is Intel, and
Unfortunately, yes.
yes, you said you have some also AMD version working somewhere.
Yes.
Oh, and I ran out of time.
Okay, that was the question. You asked about the AMD. Okay.
Yeah, my question was how far it goes with AMD and if this sysnet not starting problem also affects AMD.
Just confirmed on Intel.
Okay.
Not sure whether it is on AMD possible. Yes. So this is the screen I have showed you on the initial slide on my presentation. So the difference here is you receive a .p code that you generated during the provisioning of the TPM and the whole Anti Evil Maid feature. So basically I can now check with my authenticator whether this code is correct. So it should be 889742. Correct. So now I'm safe to type in the password because this .p code shows me that the state of the operating system components have not been tampered since my last boot. So there was no Evil Maid and she didn't install anything to steal my secrets. So now we will encounter another delay because the systemd will wait for the sysnet, firewall, and sysUSB to be up, and the timeout is about 2 minutes until it gets to the login prompt, until it eventually gives up later, which will of course show
another chance for the
yes,
questions?
yes, please do, because
yeah, please. Yeah, I have like maybe comment. So first of all, like you should not care that you didn't show the PCRs. Like who cares? We care only about the Qubes OS security report and those greens. Marks.
Yeah,
Green check mark.
This is the
marks.
most important thing.
Yes,
like,
of course.
who cares about the value of PCRs? Let's be honest. Okay. So, can you tell a little bit more about this, like Intel vendor lock-in from 11th Gen? Because like this is something new for me, and I should probably know that earlier.
well, it is also new for me too because I was like working on it for the past couple of days, last weekend and stuff. So basically what happened since 11th generation is that Intel decided to merge the bootguard and the Intel TXT, so the DRTM technology, with the firmware static root of trust technology. So it occurred to be so tightly coupled that you have to provision bootguard in order to enable TXT. So the whole provisioning and preparation configurations relies on the configuration of Intel Management Engine actually. So you have to provision the configuration of Intel Management Engine. Then when you build the BIOS, you have to create manifests which you describe what bootguard should do, what should measure. You should also describe how TXT should be configured and then sign those manifests. So that's the main difference compared to the let's say 10th generation and older, where you simply put the ACM and do the TXT initialization during the BIOS flow. So it is like a dramatic change, which like I don't necessarily like. But yeah, we will have to live.
Does it involve putting your key in CPU or any other like one-time programmable change?
For testing, no.
Okay.
You just need to configure a mean which involves injecting the key hash into its firmware region somewhere, which is used to validate the first manifest, and then the first manifest has another key hash to verify the second manifest, which actually holds the whole configuration and data that is supposed to be consumed by the microcode and all this boot ROMs and stuff. Okay, so let's go to the loved check marks. Oh, this time Sysnet started actually. Wow.
It's not end of the demo. Like,
Yeah.
let's look at the green check
It
marks.
happened to me once that it actually launched all the VMs, but it was like, I don't know, one case out of 20. Like,
Just because Mark is here.
or we did such a long, talking before actually typing those passwords. Maybe this was the case. I don't know. Yeah. And drums, please. Yeah. So, as promised, I wanted a.
See some Wi-Fi? Is it actually talking?
Yeah, click on the network manager icon.
Click on the network manager.
Yeah, available.
Available?
Yeah.
Yes, it works. Once it launches, it works. But if it doesn't launch, then of course the result is obvious.
Sometimes it doesn't launch, so that's
Yep.
the point.
That's the whole point.
That needs debugging. What worries me for this new generation, from my perspective, like from 3M Dev perspective, this essentially will complicate the procedure of delivering the Anti Evil Maid on the devices, and will probably rise its price, because like that means like someone will have to spend way more time, and it will be more complex to manage, because in addition we have to deliver those manifests, those Intel bootguard manifests, which
Anyway, you have to deliver the proper firmware.
That's like I assume that it would be in the first place anyway, but
Yeah. So as you can see,
firmware configuration, I guess.
as you can see,
From what I understand.
those PCRs have been populated according to expectations, because otherwise these 70 to 22 are typically all FF and they are locked, cannot be extended. So DRTM allows us to extend those and use them in our policies for unsealing secrets.
that's for those who don't believe the green marks.
Yes.
Which command did you use?
Cut.
It was just the TPM tool PCR read.
Thank you.
Yes, and the HCL report
And
also is.
if I see correctly, we see this is the legit value because it matches the slides you show before.
Ah, okay. Yeah, it was taken
Looks
from
the
this
same.
particular laptop. That's yes. But I don't know if the PCRs I showed on the slides were actually from this machine. It was taken from a blog post, so it probably will be different.
Okay.
I think. Because I have made some modifications to Zen because of this capability reporting. Okay, so let's go back to our slides. Right. Okay, so Evil Maid had an successful attempt, so she's angry now, and let's go further. All right, so like I said, there are issues. I want to resolve them first of all because otherwise the system is unusable. Next, we would like to offer this Qubes OS certified device with the pre-configured Anti Evil Maid, and of course the firmware supporting this feature. Thirdly, UEFI support. Yes, because every device now runs UEFI and there is no legacy boot support anymore on the newest devices. So this is also very major and wanted feature. And fourthly, it would be great to have on the newest line of Nova Custom laptops, which are also already certified according to Marek, which he mentioned it already in his presentations. But of course, it is like another effort to get it working because Intel changed things a little bit again. Yeah, and of course, I would be glad if you could support us. You can scan this code or just click the link to sign up for some tech preview for the NV40 series. And of course, when the Meteor Lake devices will be available, possibly also for the newest series of the laptops. Yes, and questions. Yeah, I went through all that. Thank you.